minutes earlier. Slower pace.
That's true.
Let's see. Three and then there you go.
Thank you so much.
Thank you.
I'm so sorry. Okay, it's like one of those clippy things.
There you go. Is that a new shirt, Ben?
Yeah. Say, I did get one of the note papers from last class.
They should be over there in that basket. To the left of the table.
He has like a little bit of a beard and a little bit of a mustache. He looks different now. Yeah. I don't know. He's different.
Mr. Thompson, do you know when you're gonna quiz them?
Last time we asked.
The quiz,
Yeah.
I'm still
but
trying
he
by
said,
the
like,
end
he
of
didn't wanna
today.
say, so I didn't like ask him.
Miss Cross got hers graded and we
Yeah.
agreed on the curve, so now I just need time to get to it, so.
She did one on the curve?
But yeah, and I saw his like husband side of.
Well, we look at both scores before we determine the curve, so we give the same thing.
Yeah.
So I was waiting on her for that, and now that that's done, I can.
Okay.
It was good. I got a pretty easy version of
Yeah.
Did it say live here? First thing was the quiz, and then the second one.
Did the letter I showed you?
Yeah, let's see which version it's in. Just that here. Sebastian. Lincoln. All right, first thing we need to do is finish up those notes from last class. So you need to find in your binder number 17. We didn't do the back page, and I wanted to talk about that middle page for just a second as well. then after that, we're going to practice a couple of those question types on that middle page that we talked about last time. So the definition of a derivative, being able to narrow it down through multiple choice. I think we did 2 of those last class, but I think we saved a couple. So I'm going to have you do that one Khan Academy assignment to get a little bit of practice in there. And then we will look at some basic derivative rules and start to practice those. So if you didn't hear me say before, Unit 2, our second unit here, is about 90% just about taking derivatives. What a derivative is and being able to take them by hand. So that's like the next several weeks of class. But then we'll keep using derivatives the rest of the semester. Okay. So on page 2, to finish up these notes, we had talked about there's 2 different forms of the definition of a derivative. And so before our next assessment, you'll need to memorize these 2. And even though you don't have to do a derivative by hand, by the definition, like we did here, you don't have to go through all of that. I'm going to show you a shortcut on how to do that this class period. We still need to be able to at least figure out what's going on through some different choices. So looking at this one, look up above. Does this look more like the top, the standard definition of a derivative, or the one below it, the alternate form of the definition? Okay, so if and when you memorize that, it's going to look like this. Now, one thing that I guess can be a little challenging about these questions is you look at this, you see 3, but then you also see f of x. Well, it could be that they plug the function in here and they don't plug in numbers yet, or it could be that they take the function and they've already plugged in a number and simplified, and that's what's happened here. So it's kind of hard for me to see the function out of this. But if this is supposed to be f of x plus h, and this is square root of 9 plus h, that sounds like x is what? X is going to be 9. But more importantly, what is the original function out of that? Square root of what? No, the plus h is there because that's part of the form.
Square root of 9.
Okay, but the function's not going to just have numbers in it, it's going to have x there instead. So the function is square root of x. They're finding the derivative at 9. But there's only one that has that right, square root. Again, that plus h is not part of the function. The plus h is there because it's part of the form that it matches up with. The 9 is there because that's the value they're plugging in. Sometimes it could be an x, sometimes it could be a number. But if it's a number, we know that that substitution is being made. But there's only one with this f of x, so that makes the process of elimination pretty quick. Okay, so this one we need to look at the choices. So do these choices look like the standard or alternate form of the definition?
Standard.
Okay, so I think it helps to write it next to the question instead of looking to the top of your page all the time, because there's some stuff that we should expect, and that kind of helps narrow it down. All of these are as h approaches 0, so unfortunately that doesn't narrow down anything because they all have that. They're all supposed to be over h. They're all over h, so that doesn't help that. But let's see, this is supposed to be the function, and so I'm looking at my choices here. None of these have x in there, so they've already plugged it in. So if I'm trying to find if the function is e to the x, but they're plugging in e because we want to know the derivative at e, then the function at e would be e to the e, which would be choice B or D, or I'm sorry, B or C. Do you see how those are set up with the correct thing? This is just e, this is just e, it's not the function at e. Here's the function at e because that's just what they're trying to take the derivative of, so that's why it's e to the e. Okay, and then these two are almost the same thing. So for this one, do you see how we plugged in, okay, we plugged in e for x here and here? Well, if you're plugging in e for x, then you got to be consistent. You wouldn't just do that sometimes and not other times. So it's like right here, why didn't they plug in e for x there if they plugged in e for x there? So it would be choice B. Now, I don't know, maybe that's not the way you would look at them, but this form is giving you hints about what the function is. But those would be the way to write the standard definition. And again, this is how College Board will ask it on your AP exam. Probably won't be more than a question or two, but this is an important topic. So, well, I don't know. I'll let y'all pick. Do y'all want to do the Khan Academy on this topic first, or do you want to do the back page first and then the Khan Academy? Back page first, okay. So in this unit, Unit 2, it's about what a derivative is. So far we've only talked about derivative, basically means slope, looks like a tangent line if you sketch it, and what the definition is in alternate form and how it looks on the AP exam. But in addition to being able to find derivatives, we also need to be able to know some basics about them, even in Unit 2. So what would you guys say that this, what would you estimate the slope at x equals 4 to be? Yeah, we're just going for simple. Do y'all see how the slope there is basically 0? Yeah, it's a tiny bit off, but that's just my mistake. All right, what about the slope at 6? Not 0. Huh? Not 6 either. Which part of the line are y'all looking at? Over here or over here?
I don't even know.
Exactly, that's the problem. If I want to know the slope at 6, you don't know if you're looking at this line and thinking about like rise over run, or if you're looking at this part of it, that I guess you could try to sketch the tangent line and try to guesstimate rise over run. But there is no slope at x equals 6. What do both of these points have in common? Well, they both have a hole. But remember, slope basically means derivative. So we could take the derivative at x equals 4. Actually, I lied. Since it doesn't exist, we couldn't. But this one's a little. This is what I really want you to get out of this. If this guy doesn't have a clear slope because it's not doing the same thing the whole time, over here this is fine. This we could calculate slope no problem. Over here we could calculate slope no problem. Couple places over here we could give some pretty reasonable estimates. But here you don't know whether to look at the left side or the right side. So if we can't answer the question for slope, we can't answer the question for derivative. They basically mean the same thing. So in order for you to be able to take the derivative of something, known as differentiability, it has to be continuous. So I told you that idea of continuity is important and it's going to show up a lot. But if a function's not continuous, we can't take the slope at that instant. So over here, actually let's go back. 11, we really should say none here as well. I'm making the same mistake that y'all did. If it doesn't exist there, then there can't be a slope there. I guess if that point had been filled in, 0 would be a good estimate. Okay, so we kind of are narrowing down when sometimes you can take the derivative, you can answer slope, sometimes you can't. So we need to narrow down and state what has to be true for it to be differentiable. What can you take the derivative of? Well, the first part is that it must be continuous, which implies that the limit from the left of the function is the same as the limit from the right of the function. If you want it to be differentiable at x equals a, then f of a has to be there, and the limit has to exist. It's got to be continuous. That's what it means to be continuous. Okay, for number 2, we'll say mathematically these are called cusp, but no cusp. Cusp are like sharp points. The slope can't change radically at an instant. If I ask you what's the slope here or the slope here, you can't answer that. So we can't say that there's a derivative. Okay, and the slope must exist, such as like if we had something that looked like this, if part of the line is vertical, we say that it's a undefined slope, and if the slope's undefined, then the derivative doesn't exist either. So, as long as the slope exists, it's not a vertical line, the line's continuous at that value, and it's not a sharp turn called a cusp, what we're really doing here is we're thinking about the slope before and the slope after. Right before and right after have to be the same slope, the same derivative. If the slope changes instantly, sharply, that's a cusp and you can't take a derivative there. Okay, so an example of this, number 17, what is the slope at x equals a? So right there, what would you call that slope? Okay, so if the slope doesn't exist, you need to know that the derivative also does not exist. Again, derivative and slope are like 99% the same thing. The slope doesn't exist, the derivative doesn't exist. Okay, so I'm going to give just a few minutes for you to try this Khan Academy. Again, it's just one assignment with the standard definition. So I'll go around the room, and as it looks like people are finishing up, we will move on. If that's too fast for you, then you'll need to go back and try it again later for homework. So, but I'll record that score at the start of next class, which is not, I'm sure you guys remember, you've got a 3-day weekend, so I won't see you on Monday, so I won't see you again till Wednesday. But
Oh wait, so it's Tuesday gonna be night day?
Tuesday's gonna be a seed. We're not gonna see.
Oh, today's night day. Alright. I was confused.
so you got plenty of time to do it, but of course you may forget it if you don't get it done right now. So try it. Look at that second page. That's where I stole some of those questions from. Pick out if it looks more like the standard definition of a derivative versus the alternate version of the definition. And get enough clues to narrow it down to one choice. And like all this Khan Academy stuff, you're welcome and encouraged. If it takes you one try to get them all right, that's great. I want you to be done sooner because you know it. But if it takes you 20 tries to first click, then it takes you 20 tries. So, and we're not going to spend too long here. So basically, when I see most people are finished, we'll move on as a group. And if you're just lagging behind, you can do it from finish it from. couple more minutes and then we'll move on. Let's move on here. So again, if you didn't get 4 in a row right there, you're still welcome to do it for homework. I won't record your score until the start of next class, so you can still get the full points, but you do need to practice that skill. All right, on to this handout. So this is getting into some of the basic rules. This is the stuff that the derivatives that we bothered to memorize so that we don't have to do that standard definition all the time. So first off, we've got the standard definition of a derivative, so you should still know that. Notice there is a different way to write it. Instead of saying h, sometimes I do delta x, which just means the change in x, but same thing. That doesn't really matter for today. Okay, so the first type of derivative you need to know how to do is how to take the derivative of a constant. So if I want to know what is the derivative of 6, let's sketch that graph. What does y equals 6 look like? What does the line y equals 6 look like? Okay, it's a horizontal line, and what's the slope of a horizontal line? 0. So the derivative, bless you, this notation means the derivative of a constant is always 0, because a constant always has a slope of 0. So like this one, this is like y equals -2. The derivative of a constant is always 0, because the slope of a constant function is flat. It has no rise. Okay, the big one, which is the power rule, this is the one that really saves us from having to use the definition a million times. The power rule says that if you want to know the derivative of x to the n, is the same thing as n to the times x to the n minus 1. So this is what it's going to look like in your textbook. But really all it means is you bring the power down. So if the power was n, you bring n down out front. So the derivative of x squared, you're going to start off by bringing the 2 down out front. And then this just is telling us to lower the power by 1. Whatever n was, subtract 1 away from that. So the derivative of x squared is 2x. Bring the power down, lower the power by 1. So what do you think the derivative of 8x would be?
8x to the 7.
And that's it. Bring the power down, lower the power by 1. X to the 5th would be,
5x to the 4.
okay, and then somebody else. What about x to the 1000? Yep.
1000 x to the 999 power.
Which is pretty silly, but that's the way it works. Bring the power down, lower the power by 1. Okay, if we have a number out front, it's just going to make it that much bigger. So if we have a constant 2 out front, you can still apply the power rule the same way to me. It's just that if you're going to bring the power down and there's already a number there, you multiply those together. But you still lower the power by 1. Bring the power down. If there was already a number there, multiply it by what was there and lower the power by 1. So the third one would be what? 4th. And somebody else, the last one.
4000 x to the 1999 power.
Bring the power down, lower the power by 1. There's a number out front, it just makes it that many times bigger. Okay, so unlike limits, if you remember limits, the add, subtract, multiply, and divide parts all kind of work out the way you expect them to. Add, you work them separately and add. Subtract, you work them separately and subtract. Multiply, you multiply, or work them separately and multiply. Divide, you work them separately and divide. Unfortunately, it does not work that way with derivatives. It only works that way with derivatives for add and subtract. For multiply and divide, we will have to learn a process called the product rule and the quotient rule, but that will be for another day. Add and subtract, we can just do them one step at a time and then either add or subtract. So the derivative of 2x squared would be 4x, and then plus, so plus, and the derivative of 3x to the 8th would be 24x to the 7th. Just work them separately and then throw the plus sign in between. Work this guy out, bring the power down, lower the power by 1. What about this one? What's the derivative of 7x?
7.
One more time. 7. Good. You can still do the power rule, it's just a little harder to see what to do. It's an understood 1, so when you bring the power down, it doesn't change anything. And then when you lower the power by 1, what is x to the 0? 1. So, you know, we're not going to write times 1. But also, if you just think about the equation y equals 7x, he has the slope of 7, right? So his derivative is 7. Remember, derivative just means slope. Okay, and if there's a bunch of terms, you just do it a bunch of times. So first part, what is this derivative?
10x to the 4th.
Okay, and then somebody else, the second term,
6x.
minus 6x, and then
Plus 9.
Minus 16x to the 3rd.
just the plus 9.
Yeah.
You brought the power down, you need to lower the power by 1 too.
Oh,
It's still
oops.
x to the 8th. And then last part would be minus 16
16x to the 3rd.
x to the 3rd. Okay, you guys, you don't have to get this out, but I want to just very, very quickly look at these notes we did last time, because I want you to really appreciate how convenient this power rule is. To find this definition last time by the derivative, we had to know the derivative, we had to plug these parts in, we had to do a bunch of algebra and get it out of indeterminate form to get it down to this. But now that you guys have seen power rule, and it doesn't take a ton of practice to get, what's the derivative of x squared? What's the derivative of negative 4x? And what's the derivative of a constant like 3? So plus 0, but of course that doesn't change. So we get to bypass all of that work by knowing the power rule.
Why didn't you tell us that earlier?
Because you need to know where the derivative comes from. You need to know that why this works for the standard definition.
We did that. That makes sense.
Okay, so I just wanted you to have some appreciation there. It really does make our life quite a bit easier. Okay, there's some others though. So the thing with derivatives is there's a handful that we have to know just off our head. So eventually there'll be some that we only do with a calculator, so we'll use a calculator for those. There's some that are power rule only. There'll be some that are product rule and quotient rule that we'll learn another day. There's a process called chain rule that we have to do at the end of all of these questions, but we're looking at real basic ones right now. And then there's a few that we have to memorize. So for the whole course, there's only a few things you have to do for derivatives. Memorize a few, know how to do a few in the calculator, product rule, quotient rule, chain rule, and power rule. But you guys have already learned power rule. So, and calculator doesn't take but just a minute to learn. So some of the others they expect you to know is the derivative of sine and cosine. These come up all the time. So the derivative of sine is cosine, but the derivative of cosine is negative sine. So one of them tacks on a negative out front. Okay, and then we could do more than one term. The derivative of cosine is negative sine, and then separately the derivative of sine is cosine. If I put a 3 out front, how do you think that's going to change the derivative?
Cosine.
Alright, just makes it 3 times bigger. And then this one would be, what's the last part of this?
Negative 4 sine. Plus 4 sine.
Derivative of cosine is negative sine, so it becomes a minus a negative. So you will have to remember which one becomes a negative, which one doesn't. And to add on the fun here, in second semester when we integrate, we go the opposite direction. So then you have to remember the rule opposite, which is kind of tough at first. But sine becomes cosine, cosine becomes negative sine. Emphasize the negative. Okay, we need to know the derivative of e to the x is a big function. This is the easiest one to learn because the derivative of e to the x is e to the x. It's one of the few functions that is its own derivative. You make it 5 times bigger, the slope's going to be 5 times as much. The derivative's going to be 5 times as much. So the derivative of 2e to the x would be 2e to the x minus the derivative of 5e to the x would be 5e to the x. The derivative of e to the x is e to the x. Okay, and then logarithms. This one's pretty important. The next one, not so much. We don't use the derivative of log too much, but the derivative of natural log of x we use quite a bit. And it is 1 over x. The derivative of natural log of x is 1 over x. So if I make it 2 natural log of x, the derivative of that would be twice as big. And now I want you to try this one over here. Try to take that whole derivative with some of the stuff we've talked about. Okay, and that's all the time I'm giving you because all 3 of these parts should be pretty quick. What'd you get for this?
2 over x.
Okay, so you have to have that part memorized, otherwise it's pretty fast. What about this? Okay, e to the x is still e to the x. And then the last part, very good, minus 8 sine x, because the derivative of cosine is negative sine. So very much can do more than one of these at once. Okay, other logarithms, as I have noted here, these don't show up very often, but they can show up on the AP exam. This is not one I would worry about at this point, but let's go ahead and document your notes anyway so you have to look back at. But if you call this down here A, and the thing you're taking the log of B, you can do 1 over B, and then in the denominator, natural log of what the base is. So 1 over what you're taking the log of, and then natural log of the base in the denominator. So over here we could do 1 over x, natural log of 9 for that part. What about this part though?
So 1 over x.
Very good. Remember, log base e is just a different, is natural log. We usually just say natural log, but they mean the same thing. So that one we memorize. I don't know. I could show you why this one works out the way it does, but again, it's just not as important, so we'll just skip that for time being. All right, so in a few minutes when we move over to our book practice, this will be our first book assignment of the year. We can just use the power rule, but you have to be very intentional in the way that the function looks. You cannot apply the power rule to this yet. If you rewrite this with exponent rules and call this x to the negative 2, which is kind of unfamiliar because most of the time in math, if you have a negative exponent, you move it to the other side of the fraction to make it have a positive exponent. But in our case, we need it to look like this to apply the power rule. Now I can bring the power down, lower the power by 1. Make sure you're not adding 1 to the exponent, you're subtracting 1 from the exponent. And then sometimes we need to simplify this. Most of the times we do. And by simplify it, I mean rewrite it so that it has a positive exponent. Negative 3 exponent in the numerator is the same as a positive 3 exponent in the denominator. So you have to rewrite it to make it look a certain way. It's got to fit a certain format before you can do the power rule. You can't just do the power rule of the numerator and then do the power rule of the denominator. It doesn't work like that. Okay, what about this one? How can I rewrite this? Instead of calling this the 5th root of x, I could call it x to the 1/5, good. Just like square root means an exponent of a half. A 5th root is like an exponent of a 5th. So if you change that, now we can do the power rule. We can bring the power down, lower the power by 1, and then if it's a negative exponent, you need to move it to the other side of the fraction to give it a positive exponent. And you don't have to do this all the time, by the way. A lot of times with power rule, you don't even have to do this, but I just need to make sure you don't fall into the trap thinking that these are all ready to go. Okay, and then over here, we could simplify this a bit. This is like x to the 1/2 over x to the 1st. And what happens when you try to divide things with the same base? Subtract the exponents. So you've got to make it look this way before you can even do calculus. You've got to know your exponent rules, your fraction rules, all that kind of stuff. Now that it looks like this, the calculus says bring the power down, lower the power by 1, and if it's got a negative exponent, you can move it to the denominator and make it have a positive exponent. Now, once we learn the quotient rule, you'll be able to do the same question in a different way, but I'll be honest, this is still much more simplified. So, okay, and then on to the last piece here. When it comes to derivatives and tangent lines, one of the most commonly asked things is horizontal tangent lines. So just like horizontal lines have a slope of 0, horizontal tangent lines are when your graph temporarily has a slope of 0. So looking at this graph here, where do you think, what x values do you think that the tangent line has a slope of 0? Okay, I agree. At x equals 1, looks like at that instant there's a slope of 0. But there's some others. Okay, I agree with 3. 2 is almost undefined, but certainly not 0. 0 is going to be straight left and right.
5.
Okay, 5. And I'd say that's probably it. Now, the reason why these are important, if you look at your graph, most of the time, not always, notice x equals 1, this is not true, but most of the time, horizontal tangent lines occur at maxes and mins. And max can mean profits, if that's what the function represents, and so you're interested in when you're getting the maximum profits, or your function could represent cost, and you could be interested in minimizing your cost, which would be the lowest value. So max and mins are important, and they have to occur when the slope is 0. So it doesn't guarantee it, but that's what naturally makes horizontal tangent lines 0. Okay, so why do we care? It's probably a max or min. Okay, and in context of this question, imagine this graph represents the distance you are walking away from home at any given time. So at the start of measuring this, you're like 2 miles away from home. So what are you doing during this time x equals 1? Yeah, you're at rest. You're not moving. At that instant, you're not moving closer to home or away from home. So the context of the question can tell us a lot about what's going on there. Okay, a function has a horizontal tangent line when, okay, well what do all these have in common? Why are there horizontal tangent lines at x equals 1, 3, and 5? Okay, slope is 0, and in calculus terms, that means his derivative is 0. When the derivative is 0, you have a horizontal tangent line. Horizontal tangent lines often represent something important when we're talking about real-world problems. So we're going to look at just a couple of examples of how to find horizontal tangent lines for these functions. So looking at this one, when you see this on a test, AP and R class, you have to know horizontal lines have a slope of 0. So a horizontal tangent line is when the slope is 0, which is the same thing as saying when the derivative is 0. So you'll have to be able to find the derivative. You'll have to know to set the derivative equal to 0, and then you have to be able to algebraically solve this. Well, we can try to solve it. We could subtract the 1 and divide the 3. We could take the square root of both sides, but the square root of a negative is imaginary. So imaginary numbers don't show up on a graph. So I don't know what that graph looks like, but I know it has no horizontal tangent lines. That graph has no maxes or mins. No time where that graph levels off, even temporarily. Okay, if we do this one, again, horizontal tangent line means where the derivative equals 0. So you'll need to be able to find the derivative, know why you're setting it equal to 0, and then solve the algebra. And that can be very easy to very difficult. It just depends on the question. This one we could subtract the 1 and divide the 4. I'm going to switch these two. How do we go about solving exponential equations like this? Okay, so we could take maybe the natural log of both sides. This simplifies to x. And should this be my final answer? Natural log of negative 1/4. See anything wrong with that? What rule thing? I already did the derivative. I don't need the derivative again. It's okay to take the log of a negative number?
No.
It's not okay to take the log of a number. That doesn't exist either. That one also has no horizontal tangent lines. I know it's been a couple weeks now, but if you remember, we insisted you guys review some log properties. And again, it's for stuff like this. We'll review it as it comes up, but you guys are on the hook for all this old stuff. Just shows up naturally. Okay, and then one more example. If I want to know where or if this has any horizontal tangent lines, I have to know horizontal tangent lines occur when the derivative equals 0. So I did the power rule on the first term. The derivative of cosine is negative sine. And then how would we go about solving this equation?
Would you isolate A?
That's what we're going to try to do. So what would be the first step?
Square everything.
Mm,
Plus 2 sine x.
I wouldn't do any of that. Pretend this is just as x for just a second. If I'm just trying to solve not sine x, how do you normally solve this equation?
Without everything went to try and square everything.
Okay, how about we undo the add or subtract first, undo the multiplier divide next. Now here, to be honest, we do kind of hit a little bit of a roadblock because we can't finish solving this with algebra. We would need unit circle. So the directions say in one rotation from 0 to 2 pi, where is sine square root of 3 over 2? So there's two places where the y value is square root of 3 over 2. So that one has two horizontal tangent lines. If you want to graph that in your calculator, you'd have to change the axis and stuff to be in terms of pi, but you could. So I'm sure I probably mentioned this, and I will be sure to mention it another 50 times, but usually what's the hardest part about calculus is not the calculus. It's all the other stuff you've learned throughout the years, being able to pull it together. Power rule is what we're introducing here. Knowing horizontal tangent line is when the derivative equals 0, but most of my work, most of the struggle just comes from unit circle, log properties, simple solving, but that is the way it goes sometimes. Okay, do y'all have a question you'd like to clarify on this before I switch the screen over? Okay. Then on one of the pieces of paper I asked you to get out, if you would copy down that assignment for number 20 and start the first few questions so we can see how it's going and see what I need to help out with. You will need a textbook today. Make sure you grab the calculus book and not a pre-calculus book. In Google Classroom yesterday, I did share the ebook, so you should probably try to download it and see if that's going to work for you. Or if you would prefer to check out a hard copy of the book to take home and leave at home, that is fine too. I can do that for you today. I'll be honest, we don't do a ton of assignments out of the book, maybe like 10 book assignments all year. If that impacts your decision. And just so you guys know, when you need a book, I always have that little sign up there by the handouts telling you that you need a book for the day. So you can grab it on your way in. And then you can put it back on your way out.
Are we checking out books this period?
I can check you out of books
Okay,
now
yeah.
if you want one. Just bring me the one that you're going to use during class, and then I'll sign.
I check this one out. Yeah, I'd rather have it just because if I leave it, then I'll forget about it because it's not for me.
Yeah, it says you almost have $20 of fine, so I don't know what that's about, but make sure you put your name in here,
Okay.
and then that way don't leave it here. Take it home because it's checked out to you. Okay, guys, wait on the books. I can't help more than one person at a time anyway. No, you're fine. But there doesn't need to be a line up here. Y'all sit here and do it. Okay, this is Sam right here. Is that an old picture?
Yeah, it is. Well, I'm actually not that old, I guess. A year old.
Okay. Does somebody else want to check out a book for the year? You can always change your mind later too. Okay, come bring your book up then.
Mr. Mountain,
Yes.
what's the course key for the web assignment?
We're not doing WebAssign this year.
But for like the ebook,
Yeah, we're not doing WebAssign this year to have access to the ebook. I posted the ebook in, here you go, in Google Classroom. Again, find the ebook in Google Classroom post that I posted yesterday if you want to try that.
Oh, we can return this anytime, right?
I'm sorry.
We can return the book anytime, right? Do we just keep it in here?
Just keep it until the end of the year. No, that one you take home.
Oh, okay.
Yeah, if y'all checked out a book, you should put your name in the cover. You should take it home and leave it home. We have enough for a classroom set here, so you don't have to bring them back and forth. And you'll just bring it back at the end of the year. If you don't think you want to check out a book and you change your mind, you can still change your mind later. I may not check it out to you in the middle of class if we're doing something else, but I don't mind you checking out a book. You can also use the ebook if that works for you. That's why I said you should try it in Google Classroom. And honestly, as rarely as we use it, sometimes you could just take a picture or two with your phone, the couple pages that you need. But these first few questions you guys should be going through pretty quickly here. So they're not meant to be super long questions or anything.
Slope would be 12. Slope of the constant is always 0.
Now, I might want to leave your notes out for this.
Mr. Johnson, we need to find the volume of the menu this year.
Well, you're going to do volume questions like that, yes. You might.
Oh, the menu. Yeah, that'd be dope.
But before you can figure out how to do that, you have to know how to integrate. And exactly. To know how to integrate, you have to know how to take the derivative, which is what you're starting today. It's a process.
Do it.
Okay, again, these first few questions should be going pretty quick, so if you're stuck and you're not sure, you should be calling me over and let me know.
The whole week? The whole week? You signed up for every day?
Friday's a pep rally, Monday's no school, Tuesday's no movement, so there's 2 days. If there's no school on Monday, then they want you to, right, you're always gonna have 1 day that's in advisory. I mean, you would need to go to advisory to sign up for the week anyway, so. Okay, I didn't show you that yet. What number are you on? Okay, just save a couple spaces for those, let everybody catch up to you, and I'll show you all the ones.
Wait, which ones are the ones that we're not gonna know?
I don't know. You'll know when you get there.
For 27, so I need to move this up to the way.
Yep.
And when I do that by making this, a negative?
Well, what's 5 to the third? 5 times 5 times 5.
125?
Okay, so I call this whole denominator, I would change to 125 x to the third.
Okay,
And then the x to the third needs to move to the numerator.
just, right.
Yeah, we don't need the number to move.
So that'd be 6x to the 1, right? No, that'd be 6x to the negative.
There you go. Okay, now you can do the power law. The numbers are kind of big, but it's still bring power down, lower power by 1.
So, what is that? Is this divided by 0?
The rest of the question.
If you divide it by the,
No, you're just doing the derivative once. So first they want you to rewrite it. Here's your rewrite. Next they want you to do the derivative. So bring the power down, lower the power by 1. Denominator stays the same though. The denominator is just a number out front.
oh,
And then they want you to simplify. So don't leave the negative exponent. Move that back to the denominator, make it to the positive.
okay.
Like that. Also, almost all of these questions are odd, so you should be checking your answers. I would recommend you check every few questions so you don't have to redo a bunch of work. But if you're doing something wrong, you need to catch that. If you don't know how to find the odd answers in the back of the book, let me know. Is she going okay? What happened with 33? Oh, that's the calculator one. That's the first one that's in the calculator thing. 31. 33. I didn't check how to do it in the calculator like that. Just skip those two for a moment. I'm kind of waiting for more people to get there. Yeah, you're not gonna know how to do 33 yet. I'm just waiting for more people to get there before I show you what to do. But you can just skip those couple questions, 33, 36, I think. So you're gonna have to, just like these, you're gonna have to rewrite it. I would probably cube to 5, call it 125. So it's like the number out front is 6 over 125. And instead of calling this x to the third in the denominator, I call it x to the negative third. That would be the rewrite step. Then when you do the power rule, you'll have the differentiation step, and then you need to simplify that. Did you like what assigned last year? Did you like what assigned last year? Were you not the one asking about what assigned?
Oh, yeah.
We decided not to use it this year. We didn't use it very much in calculus, so.
What is it? Is it like,
What is what assigned?
is it like a textbook or something?
Did you not do pre-cal last year?
Oh, was it yours?
Okay. It's, have you ever done Delta Math, maybe?
Yes, sir.
No. What else is it? It's just like a website you sign into and like you can assign problems to like, instead of giving you like problems out of the book, we give you problems on a website. And like you like have to type in your answers and it will tell you if it's right or if it's wrong and give you a chance, but then it also has access to the ebook. So we can use it this year, so. As soon as Grace comes back, I will show you guys how to use the calculator for those couple questions that say that. Not COVID, I hope. Probably just some bug that time of the year. Okay, let me interrupt you here so I can show you how to do the calculator questions. I think that's number 33. Okay, so I had mentioned throughout the whole course, there's only a handful of type of derivatives you have to be able to do. Power rule is one of them. You guys already kind of know it. You just need to practice it more. You have to memorize a few, and I showed you some of those today, so you've already put a dent in that. Like the derivative of cosine, the derivative of a constant, the derivative of sine, the derivative of natural log of x, the ones you have to memorize. And then I mentioned that sometimes they expect you to use a calculator. So this is important because even on your AP exam, they are going to ask you to do some derivatives and some integration that you literally can't do by hand. That's important, and I'm trying to emphasize it because every year there'll be some students that'll say, I couldn't figure out how to take the derivative of this one for an FRQ. And I will ask, well, was it a calculator FRQ? Because if the answer is yes, they didn't expect you to do it by hand. You were wasting your time, and sometimes you can't do it at all. So on these calculators, now if you have your own, it kind of just depends on how new it is, but hit Alpha Window, and you want to see this menu. Alpha Window. So it's really for this F2. If you have like your own, if it's a TI-83, a TI-83 is not going to have this info in there. So you'll have to borrow one of my classroom calculators. Okay, the two that we will use a lot are these two. Number 3 is for differentiation, and number 4 is for integration. You don't have to worry about integration till January. But number 3, your calculator can do derivatives for you with one catch. So, what was the first one that the calculator asked you to do, 33?
Yes.
Okay. It says, let's take the derivative of, now we have to define the variable. We want to take the derivative with respect to x because x is in the problem. 2x to the 4th minus 3. Now, your calculator won't do that derivative for you, but what it can do is that derivative for you if you tell it at a specific point. So we want to know when x is what? And it's got a little bit of a rounding error in how it does the work. but that would be 8. So if we did the same thing by hand, what would the derivative of this be by hand? Okay, 8x to the third. And if I care about where this is at x equals 1, that would be what? 8. So you see it just does it for you. Not really needed on this question, but I promise you there are times that it is needed. So one more, I think 36 is the other one. Okay, make sure you're doing it with me here. Alpha window, option number 3. We're taking the derivative with respect to x because x is the variable we're using. You can type this in, -2 cosine x plus 5. And I want to know the derivative when x equals what? So again, it can't do the derivative, but it can do the derivative at a point. Now this one I think is probably not going to be correct, but yeah, that's not correct. What could possibly be wrong about how I type that in? No, I think my parentheses are okay. No guesses? This is a trig function, right? Don't we work with trig functions in degrees and radians?
Oh,
Okay, my calculator's in degree mode, probably from something from pre-calculus, but everything in calculus is in radians. Basically, anything in higher mathematics is in radians. So, it just, ironically, was almost the same, but should be 0. Now again, that's not a hard one to take the derivative of. You could do that by hand. You can plug in pi, and you can see that you still get 0. But you need to know that your calculator is capable of this because they will expect you to use this once or twice on the AP exam. Some of them you literally can't do by hand. Okay. Go ahead, keep going. That's also fine to check your answers this way too. I know most of these are odd, but on some of, well, actually I take that back. A lot of these don't want to know the derivative at a certain x value. They just want to know the derivative. So I guess your calculator couldn't check that. Another thing you can do is if you take a picture of the solutions on your phone, then you can just have your solutions here and your problems here. Might be real fast here. can't do it this way, because you've got something times something, the way you rewrote this. So that's gonna be something that we do call the product rule later, or you can do the quotient rule here. So for now, the only thing you can do is split apart your fraction. You can put this over x cubed and put this over x cubed.
Thank you.
So you'll have options in about a week or so, but right now, you just have to rewrite your fraction. Okay, so any questions?
27.
Well, this isn't 5 times 3, it's 5 to the third. So that's 125. So this is 6 over 125x to the third. So that's not in the right format to do power rule yet. So the rewrite would be moving x to the third from the denominator to the numerator and calling x to the negative 3. That's the rewrite. Then when you bring the power down and lower the power by 1, you'll have the derivative. And then you yeah, any number that you have just leave up front. We got 6 over 125 x to the third. But you can't use the power rule with this in the denominator. So you're gonna have to move that to the numerator. Then you can do the power rule because it's set up correctly. After you do the power rule, you have your derivative answer. And then there's one step that you can do to that and simplify it. I'll be back. Hold on. I saw her go.
You just don't want to do all the forward.
Okay.
Like, I did that. I don't know what's happening.
Equation of a tangent line. So, point slope form.
1 minus by 1.
Would you split it?
Well, do we not know this one?
Okay, we'll come back for it.
Oh wait, is it 0?
Or it would be 0.
Oh, I guess it's not 0. And then x minus 1.
Okay, so remember, slope and derivative basically mean the same thing. So you need to know what the derivative of this is when x equals 1.
Okay.
So take the derivative, plug in x equals 1, and then you know what the slope is at that moment.
And then what do I do?
Plug it right in.
And then that's my answer?
Mhm.
Okay. I'm just confused what I was supposed to do.
Yeah, that's for part A. Part B, they're saying you could graph this in your calculator, and you could graph this in your calculator, and it should look like a tangent line.
Okay.
How would you do 42?
42?
Jeez.
Yeah, so until you learn some other rules. What does the numerator say?
It's 2x to the 4th minus x over x cubed.
Okay, so for you, what you're gonna have to do right now is use fraction rules. You can split this up as long as you put this over the denominator and this over the denominator.
Okay.
Then you could simplify this and simplify this. And then you can do power rule here and power rule here.
Okay.
But in about a week, we'll learn something called a quotient rule, and then you can just apply the quotient rule to this and just be done. But honestly, this might still be easier, so. You okay?
What do you have? This is the same thing.
Oh, same one. Okay.
Would you move forward over minus 3 to minus 4 first, or would you go to 4?
So would you go on?
Or x to the third. No, that's the rewrite step. That's just using exponent rules and not really done any calculus yet. But now that it looks right, it's in the right format, you can just do power rule, it's just quick. and that one didn't get simplified, so. If you have a negative x fine, you can simplify it.
And then what you can't have a negative x. So you have to.
Yeah, those stuff like that.
Okay, did you get it?
Those stuff, no, you gotta pull it out of there.
Okay, so move that up there, and then you're done with the rewrite step.
How do I get that up there?
Change it to x to the negative 3.
6, it's negative 3.
Uh-huh.
Over 1.5.
Correct. It's just that most of the time in math, we go from here to here,
Oh,
but sometimes in calculus, we need to go the other way to make it look simple. Now you can do the power rule, and you got your derivative, and then there's one step that you'll be able to simplify. Okay, I need to give you guys one reminder here at the end of class so that you can finish this up. You can see these questions, most of these questions are very quick. Shouldn't take a long time. But I need you to finish up this book assignment for homework. So either you can use the ebook on Google Classroom, or you can just take a picture or two of these pages, or you can check out a book, is fine. But for some help, I need to remind you that this class website that I asked you guys to bookmark, if the internet will ever pick up.
There you are. Thank you so much.
Okay, so the class website that you guys should have bookmarked looks like this, right? If you slide down to, oh, I need to add it on there. I'm sorry, it's not there yet. But basically, I'll do it right now. But I will have on our class website a thing like this, where every one of these questions have already been worked out. So when you're working these for homework, the last, whatever, 5 or 10 of them that you have to do, if you get stuck on one and your answer's not matching up, or if it's an even question and you don't know the answer, you can just click the link on that question, and either the video from the textbook company or me will work out that one question, usually just a couple minutes long, and then that way you can get help with the ones that you didn't get to in class. And a couple of you need to retry that Khan Academy if you didn't get 100 on it in the amount of time I gave to you. So. And again, no school Monday, so you have until Wednesday to do this. That should be plenty of time.
Still check out a textbook.
You can.
Yeah.